Hi guys, subscribe to my channel and click the bell icon so that you receive the latest updates.
In today's lecture, we are going to talk about the introduction to the projectile motion. Yes, the projectile motion is very important topics for the entry test of such as GIK, especially ETA test. Okay, in today's lecture, we are going to just discuss the introductions of the projectile motion. After that, in the next lecture, we will discuss its basics parameters. So as you know that if a body moves in the presence of the gravity, so that body is called the projectile, and the motion of that body is called the projectile motion, and the path followed by the body is called trajectory, and its trajectory is parabolic. So in order to explain the basics of the projectile motion, so consider this is a plane. We are saying this is y-axis, this is x-axis, and now if a body moves in the presence of the gravity, so it will move like this way. As you can see here, it bends with some angle. Let's have, for example, we can see we have thrown the body with some acute angle, that is theta. Now you can see here the path followed by the body is parabolic, and its trajectory, if we can say that, is parabolic. Now you are aware of the fact that the projectile motion is a two-dimensional motion, so it means here that we will be evaluated in the two components, that is y component and the x component. So be careful, you will be evaluated in MCQ in ETA like which of the following component will remain constant. So that is the x component remains constant, because we said that during the projectile motion the x component remains constant. The x component remains constant, while the y components is variable, which means that it can be changed with the passage of the time. For example, if I project a body like this way, so its initial velocities will be different. With the passage of time, its velocity will decrease, and at the summit point its velocity will be zero for a short period of time, and after that its velocity will again go on increasing. So this is the general example of the projectile motion, which we can say that the y component is variable because its velocity will be decreasing from this side, and at this point its velocity will be zero, and again its velocity will be increasing. But you also know that the x component, we say the x component velocity will remain constant. For example, if I throw a ball with some velocity, for example I throw a ball with 5 meters per second, so x component's velocity will be 5 meters per second from the point of projection to the point to the dead point. It will collide with the earth, or it will face something, etc. So it's, I mean to say that its velocity will remains constant, but the velocity of the y component change. But the question arises, how is it possible? Because we have a drag force, we have a spin movement, we have height of release, and these are the different angles we have. So then why the projectile x component remains constant? So as we know that the spatial convention we have taken in the projectile motion, so that we can easily calculate our calculation. That is why we take the x components remains constant, so we neglect the drag force. If we consider the drag force, then our calculation will face some complexity. So in order to avoid that complexity, we use the simple calculation, and the simple calculation is that in which we neglect the x component, such as the drag forces, the spin movement of the ball, the air. So we neglect these sort of terminologies. Now let's talk about its basics. So as we have learned that it involves the y component and the x component, so that is the reason that we also say that the projectile motion is generally two-dimensional motion, because two-dimensional is involves two components, that is y component and the x component. The y component, it shows the you may say the height of the projectile, related to the height of the projectile, and it is related to the range of the projectile, which covers some distance. So we say that the y component and the x component. Okay, now as we are aware of the fact that v naught is our total velocity, and that is equal to the v cos theta, or I vector plus, that is unit vector, and v sine theta, and j vector. So that is our interested relation. You know that the velocity will be equal to the v cos theta, which is related to the x component, and the v sin theta, which is related to the y component. So we can say that it's our horizontal component and it's our vertical component. Okay, these were some of the important points of the introduction to the projectile motion. Now let me add some more sugar here for the conditions of the projectile. So the condition of the projectile is also one of the most important condition of projectile. Okay, we says that if you want our projectile motion, so we should apply velocity. We should give a velocity at least which will be greater than 0, then we will get our projectile. Similarly, if you want, so it is always two-dimensional motion. So if you want a two-dimensional motion, so we have to throw the projectile with some acute angle, So these are the two important conditions for the projectile motion.